Hi, I'm ED-SKaR, and today Alice Coat Duck has asked me to do a review and kind of tear down, as it were, of her new Malice cage. This is a parametric flywheel cage, which is a fancy way of saying it can be altered to fit just about anything that you want it to. So as I understand it, she has the screw ports of various different Nerf shells, so you can choose which Nerf shell you want to put the cage in, and it will give you the screw ports in the right position. You can also change the distance between the center of the flywheels, so you can have whatever level of crunch you want. That's of course important to balance the distance between the surfaces of the flywheels, depending on what flywheels you're using, what motors you're using, what FPS you're getting, what darts you're using, and all the other things. So you can alter this to be just about exactly what you would want. And just to prove the point, when I was asked what spacing do I want between the motors, I asked for 42.33. And that's exactly what I've got. So this is probably the world's first 42 1/3 flywheel cage. And on the back there, if you can, I'll probably show this off on a different angle to get that to come through. That is the Malice logo, which is absolutely beautiful, of course. And for most builds, particularly Strife is most famous for it, but just about anything, if you're using humongous motors, you cut open the side of the shell to fit in usually 180s, sometimes 132s if they don't quite fit, or 140s. And because you have that opening, you can put in, instead of covering it over completely, you can put in a window to show off your motors. Now in this case, you also get to show off that you have a Malice cage. And as I said, this particular one hasn't come out fantastically, probably because I print just about everything with a brim. And every single line of that logo has a brim on both sides. So I might carve that out. And if you hear the printer in the background, that's another one coming out that I'm going to do something slightly different with. As a separate piece, there is a dart guide. So this sits into the magwell and sits just above the front of the magazine, which helps with darts not popping up out of the top of your magazine, which is one of the common causes of jams, particularly with old and used darts. They don't hold in the top of the magazine and pop out and just cause you problems. So this helps prevent that. Most 3D printed flywheel cages have something similar. The difference here is because this is a separate piece, it prints perfectly. Usually you would end up printing the cage so that this is on its side and you have so much support material underneath it that you end up having to spend a long time cleaning that up, and it's sometimes warped, depending on your print settings, of course. In addition, the lines are in line with the dart, which means that particularly if there's any roughness there, it can cause some wear to your darts, which usually isn't a problem, but occasionally is. Because this prints this way up, you get a nicer surface on the inside, not perfect, again, depending on your print settings. But that is much easier to make and then attach on. And of course, being Alice Coat Duck, she says to use CA glue. I'm sure that all of the rest of you get on just fine with CA glue, and you can use CA glue and it's probably just fine, but I'm allergic to the stuff apparently, so I should be using something else. So to nerd mention some things about 3D printing, this surface is the surface on the print bed, and the inside of the motor wells had support material, so I've pulled that out. I haven't cleaned it up yet, I've only pulled out the support material. And also underneath the screw ports, there's support material. But that's it. There is no other support material anywhere on this design. And particularly with a full enclosure like this, I've never been able to print that kind of shape before. But on this, I mean, there's like one strand, and I'll see if I can get a close-up of it. There's one strand that's come loose, and that's easy to cut out. But just the shape of this makes it much easier to print than some of the other cages around. So let's have a bit of a closer look. Actually, that's not really close. Let me just borrow Mr. Nathan's zoom lens. Zoop, zoop, right. That's a bit better. So all the way around the inside of both sides, we have a shield. And it seems like most of that is just to support the screw ports, because at the very top and bottom, it's completely clear. So let's have a look at the Malice logo. It's not focusing, is it? And as I mentioned, because I print with a brim, it's kind of flooded some of that logo. I might try and... I'll go at it with a file a little bit and see if I can pick it out, but I'll do that in a bit. Also somewhat interesting, and this is a mistake almost on my part, that if you notice that there's almost black lines around here, the thing I printed before this, I printed in black filament, and I forgot to purge my nozzle when I started to print this. So the very last bits of black are the very first few lines of printing this. And actually, that just looks so cool. Kind of the ghost black in the purple. I really like that. So first thing to do is to clean up the support material and the brim, which is going to take less time than any other cage I've ever made before. But it does involve some filing, which is terribly boring, so time lapse. Eventually I'll work out how to print without a brim, and I will not have any of these sanding problems ever again. So, as I was saying, the first part of assembly is to glue on the feed ramp dart guide. So the internal diameter here is sized for 17/32 brass. Now, I'm an engineer, so I don't actually work in archaic. I use millimeters, and I have 15mm and 13mm copper pipe instead. However, I'm also a nerfer, and so I have ended up with some 17/32 brass, so I can go ahead and line that up. So all the brass is for lining up the cage itself. So usually what you would do here is put the brass in and super glue or CA glue the dart guide to the main body of the cage. Unfortunately, as has been mentioned several times, I am allergic to super glue, so I will be using some solvent weld, and for that I will use a gas mask, and that makes for bad audio, so time lapse. Okay, so there's that, and for anyone who was paying attention there, you'll notice that I dribbled some of the solvent, and I have left a fingerprint, or my thumbprint, I think it was my thumb, all over the top here, which is okay because that's the pretty side, which is fine. So now that we've got the dart ramp installed, we need to assemble the rest of the cage. So I have got a pair of Titan Hyperions motors and some Bulldog flywheels. These are from UK Nerf War. Excellent wheels. Finally getting some use out of them myself. So let's get the motors in. So let's get some screws in those motors as well, just to hold them in place. This is a fairly tight fit, particularly with 3D printed cages. If you get the tolerance just right, you can kind of press fit motors sometimes. But I don't like to trust that, so I am going to put in the screws. So that recess matches those screws nearly perfectly, actually. Grief, that is flush on all four. Marvellous. So they are pressed quite tightly into the PLA, so the PLA will kind of hold them in place, and because they're flush it means that they're not going to interact with the flywheels either. So next, of course, we need to put on flywheels. So there we go, with the power of brute force alone. They are on. They seem to be lined up, and oh, good grief. That is extremely tight between the Bulldogs, which are pretty high crush, and the 42.3mm cage. Yes. However, the Titan Hyperions are pretty beefy motors. I mean, they're still 130s, but as 130s goes, they're pretty nice. So that should be fine. Next step, of course, is to install it. So if we're going to test a cage, we of course need something to put it in. So in this specific one, the screw ports are spaced to fit in a Strife or Rapid Strike. They use the same design of cage. So let's see what I've got. Well, this is being sold, so I can't use that. I won't have it for long enough to actually test anything. Well, this thing's popped up on the channel a few times by now, and it's got really nice grip. Kind of fits my hand just right. But it's not exactly ready yet. And this has still got a ways to go. No. It looks like this isn't done either. Well, I guess I'm using this one then. All right. So during that section, you may have noticed that I wired in a Gate Pico SSR3 MOSFET board. This is kind of a bit over-spec'd for Nerf. This is designed for airsoft AEGs. But it's what I like, it's what I use, and I do try to keep a stock of these. There are cheaper and more appropriate options for Nerf. Now, while building this, I did realise that the Titan Hyperions are actually 132s and not 130s like I originally thought. So I rushed off and printed the Woody 7070 motor cage for the side here. But what that meant is that I actually lost the Strife name off of the side of it. And I need to be able to make sure that I know which of my Nerf guns are which. So if the Strife is missing from here, I might confuse this for a long shot, or I might confuse it for a Raider particularly. They're very similar. So I needed to make sure that I put, somewhere on this, I need to make sure I put that Strife name. So over on this side, cleaned up the logo and I glued it on this side to make sure that I could, you know, make sure I know which one's which. Also, from the logo on the Malice cage, I extruded it out and printed it and glued it on the side there, which I think looks pretty nice. And that is the smallest thing that I have ever printed. I've never even attempted to go to strands this small because I've not been able to, but in the last few months I've been adjusting and improving and various other things to my printer, and that came out nicely. Now you will notice that the dot of the I is missing, and there's a very good reason for that. It's a bit of an in-joke, and I'm not fixing it. Now also for the Titan Hyperions, the motors that I've got in this thing, they are somewhere in the region of 25 amps each, which means that the total is somewhere in the region of 50 amps. So I need to use a battery pack that's 2S, 7-8 volts, and can safely supply 50 amps. Unfortunately, all of my lipos are ridiculously old, so I had to use one that's quite large, which makes this thing noticeably lopsided and a bit strange. So what I will do at some point is I will buy a battery specifically for this build, something that's a little more modern and can supply the motors safely while also being a little bit smaller. So now that it's built, let's take it outside and give it a test fire. Oh, good grief, it's the middle of the night. Come back tomorrow. But I think we can do a little bit better than this. So I did also try and get some cool shooting footage. Unfortunately, it ended up looking like this. Which wasn't particularly good. You may also have noticed that I have not put a proper magazine release catch in the Strife. And I've just got the internal linkage from the original magazine release system. And that's because I was always intending to use the Vorpal magazines with this. Unfortunately, this particular magwell is insufficient. It doesn't really line up very well. However, it just about worked enough for me to test it and run it over the chronograph. With the full lengths, I got kind of 35 to 38 meters per second, that kind of range. And with the half lengths, I got only a few meters per second less, kind of 33 to 35, which is well within the sight limits of just about everywhere that I play. Some of the younger kid games it would be a bit too warm for, but there's at least a few places that I can use this. That may be a little bit less than what I was expecting, given that these are 132 cans and Bulldog wheels. I was expecting a little bit higher muzzle velocity, but the cage itself certainly has proved itself. The motors, then no rattle, no crunching or vibration at all from the flywheel cage. And that's partly to do with how they're designed. So I've got this, my second one here. I've tried to paint the logo in gold and it hasn't, it's sort of come out, but not as much as I'd like. Because on many of the other types of 3D printed cage, you have an extra hole on both sides here so that you can put a tool through and push the flywheels off. If you ever need to change the motors, change the flywheels, or... Now, I've never actually needed to remove flywheels, ever. I put the flywheels on and leave them to it. But there is actually a better way of doing it that I'll have to show at some point, using two tools coming in from the side, or the top and bottom rather, and prying the wheel off like that, which gives you even pressure around the ring of the flywheel and damages the flywheel less, hopefully. Although I haven't actually done that myself, so I will at some point. But having that solid base and the big kind of shields around the side means that the cage is very solid with basically no flex to it at all. Whatever motors you care to put in this, there's no rattle, there's no kind of crunching or grinding sounds that you sometimes get with other cages. So overall, a very well designed cage, as you would expect from an engineer of coat duct standard. And the parametric parts of things means you can get exactly what you want. In this case, I may have ended up for a slightly looser cage than I may have needed. But that was because I wanted to make the joke of 42 1/3 millimeters, just to prove the point that parametric means you can choose any point within the range and have that. And I will be bugging Alice about making a canted version as well, with probably parametrics to change the angle of the flywheels. Now we've got 8-degree cages have existed before, which for kind of 30 meters per second or less is just fine. But once you get above that, and certainly once you get above 40-45 meters per second, an 8-degree cant is far too strong a cant, and we need less. So I'd like to see parametrics in the order of ½ a degree up to probably 8, and you can choose any point along that depending on what your build is. So that's the Malice cage, a parametric 3D printed cage that is particularly solid. I'm ED-SKaR, always have been, and thank you very much for watching. Get out of my house.